Okay students, so now I will show you how you change the temperature and then do your measurement of capacitance. So basically you are changing the temperature and the dielectric constant of the material is temperature dependent, so it changes. Because the dielectric constant changes, so the capacitance value will change. So if you remember, we stopped at the earlier experiment when the signal was minimum. Now you see I have changed the temperature here. You can see here. So this green number here is basically the temperature that I have set. So that means I have asked the controller to make the temperature 80. So I did it a few minutes back. So you see the controller has already reached 80 and it is trying to balance around 80. So whenever you do any kind of experiment using temperature controllers, so the basic idea is that the controller is turning there is a current supply that goes to the furnace, which by joule heating is creating heat and creating the higher temperature, right? So once you reach 80, it will always overshoot 80. See, now it's 85. This is the actual temperature. The red one is the actual temperature, green one is the set temperature. So what the controller does is basically it tries to turn on, turn off the current to keep your temperature round about this value. Okay. So anytime you do any experiments using temperature controller, so you have to give it some time so that it can attain a value close to this one. Okay. So that is one sort of challenge involving this kind of experiment. So this temperature controller, temperature based experiment measurement of this capacitance takes a lot of time. Okay. Now it will try to balance. So let's say now you see it has gone up to 88 when I'm set at 80. So it is now off basically. So the temperature is keeping on increasing. So it will wait. You have to give it at least 5-10 minutes to sort of get an equilibrium value. Alright. So let's say after 5-10 minutes it will achieve something around 80, let's say. So I'm not waiting for that. So when you do the actual experiment, you have to wait till it goes back to 80. So it's the current is off, but still the inherent heat that has been there, so it's still heating up the area around the sample, and that is what is being displayed here, 90. Now it's gone to 90. So you have to give it time to equilibrate. Also, this is temperature at the sensor. So the temperature at the sample might be a little bit lesser than this one. So because the heat flow has to happen and the temperature equilibration has to reach there. So anyway, so you have to allow it 5-10 minutes to go to equilibrium, so that you get this value that you have set. So let's say it has gone to equilibrium. So now you see there is quite a strong signal. So if you remember, we ended the last video at minimum. So the minimum has now changed. So I have to again readjust my resistance and capacitances, the known resistance, known capacitance. So these have the symbols C4 and R4 if you compare with the manual. So I have to change this known capacitance or the variable capacitance or the variable resistor C4 and R4 to again find the balanced position for the bridge. That means again to minimize the signal in the CRO, the voltage in the CRO. So let me change the resistance and see if I can go back to the minimum. So if I keep on, so now I am actually increasing the resistance. So you see now this is my minimum again. So I can again change the resistance, go to the minimum. So again once we have reached this minimum, again I have to note down the value for the resistance that I have set, capacitance that I have set, and then from that I have to again calculate the capacitance at this particular temperature. These are known capacitance, right? So again once this part of the experiment is done, we'll again have to change the temperature and set it to a new value, and then again wait there for 5 to 10 minutes till the temperature gets to equilibrium at that particular value, and then do the experiment. So actually there is also other settings that I can do to change the rate at which temperature increases and rate at which temperature changes happen. So now it is set at high rate, so that is why it's gone very high. So so that it's easy to display to you. So let's say I now want to change the temperature to 100. Okay. So what I can do is if you can see in your screen, there are just arrow marks here. So you just click on those arrow marks. So it will allow to change you different. It can move around the cursor and you can change the digits at different positions here. So now it is 80. Let's say if I want to go to 100. So I have to change this position, number at this position to 0, and the number at this position I must set it to 1. So I will move the cursor. Let's say there is an arrow here. So you see now the cursor is at 0, then it goes to 8, then it goes to the digit before that, then it goes to the other one. If you keep on clicking, it will come back again from the other side. So now this one I want to make it 1, so I will set it to 1. Again I will have to go to this 8 and make this 8 0, right? So I am reducing this, so I will make it 0. Now you see the number is blinking. Within a few seconds it will stop blinking and it will automatically read this as the temperature I want to get. Okay, so now it will turn on. You will see in a moment it will turn on the heater and it will go to that temperature. Okay, so likewise you have to set different temperatures, allow the system to get to its equilibrium value at that particular temperature. You see now there is a orange sort of LED that is on here, right? You can see it. So it says out 1. That means it is now outputting current to this oven, oven 1. It can control 2 ovens actually. But anyway, in this experiment we only need this one oven. So oven 1, it has started the output. So now it will start increasing temperature. Now you see it is 93, it will become 94 or 95 in a moment. Okay, again as the temperature will increase, again this minimum position will change. Okay, again I will have to set the resistance or the capacitance, the C4 and R4, the known the variable ones, to get back to the minimum, and then again do the calculation for the new value of the unknown capacitance. This one, this is denoted by the symbol C1 and R1, and this is the barium titanium sample that you have inside. Okay, so you see now the temperature is again started to increase. So this is basically how you perform this experiment, figure out the temperature variation of the capacitance, and then if you plot it, the capacitance or the dielectric constant, if you calculate dielectric constant from the capacitance, how to do it is also described in the manual. So you will see once you plot it with temperature, there is a very sharp maxima that it will reach, and usually it is around the temperature of 130 degrees Celsius for barium titanate. So that is the Curie point for barium titanate. That is the main purpose of this experiment. Okay, so what is Curie point and all those things again is described in the manual, so you have to check out the manual. Okay, thank you for listening.